You are standing in a parking garage. You just spent 10 minutes wandering between identical concrete pillars. Your phone is dead. Panic sets in fast. But somewhere on the other side of the planet, a hunter walks for 3 days through featureless desert and arrives exactly where he intended to go. No map, no compass, no phone. How is that possible? The real answer is far stranger than instinct or magic. It's a lost human skill, and you still carry the hardware for it buried under decades of disuse. Let's start with your brain. Deep inside your skull sits a structure called the hippocampus. It's small, curved, shaped almost like a seahorse. For most of your life, you probably never thought about it once, but it might be the single most important reason your ancestors survived long enough to become your ancestors. In 2000, neuroscientist Eleanor Maguire scanned the brains of London taxi drivers. These are people who spend years memorizing thousands of streets, an achievement called simply the knowledge. What she found stunned the scientific community. The taxi drivers' hippocampi were physically larger than average, not metaphorically, not figuratively. Larger, measurably larger, in a part of the brain tied directly to spatial memory. The longer someone had driven, the bigger the effect. Their brains had reshaped themselves around the act of navigating space. Now ask yourself something uncomfortable. When was the last time you actually navigated? Not followed a blue line on a screen? Navigated. Built a mental map from scratch using landmarks, direction, and memory alone. For nearly all of human history, that wasn't optional. It was survival. Your ancestors didn't have street signs, they had rivers, ridgelines, the angle of the sun, the position of specific stars. And their brains were built, quite literally, to store all of it. Here's where the story gets stranger. In 2014, John O'Keefe shared the Nobel Prize in Physiology or Medicine with May Britt Moser and Edvard Moser for a discovery that reads almost like science fiction. Inside the hippocampus, O'Keefe found individual neurons that fire only when an animal is in a specific location. He called them place cells. Years later, the Mosers found a second system nearby, grid cells, neurons that fire in a repeating hexagonal pattern, effectively laying an internal coordinate grid over the world around you. Together, these cells form something close to a built-in GPS, not a metaphorical one. An actual biological positioning system, evolved millions of years before the first satellite ever left the ground. Think about that for a second. Long before humans built compasses, before we drew the first maps, evolution had already solved the problem of getting from one place to another and back again. The system was already there, waiting to be used, and some people never stopped using it. Consider the Aboriginal peoples of Australia. Linguist John Haviland and cognitive scientist Lera Boroditsky studied communities including speakers of Kuuk-Thaayorre, who don't use words like left or right at all. Instead, they describe everything in terms of absolute cardinal direction. Not the cup is to your left, but the cup is to your north. To speak the language correctly, a person has to constantly track which way they're facing every waking moment, without exception. The result is a form of spatial awareness so precise that speakers can point accurately toward home from hundreds of miles away in unfamiliar terrain without hesitation. This isn't a party trick. It isn't some rare genetic gift. It's what happens when a brain is required every single day to keep building and updating an internal map of the world. The skill isn't missing from modern humans because we lost the hardware. It's missing because we stopped demanding the software run. So what happened to the rest of us? Turn-by-turn navigation happened, GPS happened, and research suggests the cost is real, not just theoretical. Studies on habitual GPS use have shown that people who rely heavily on turn-by-turn directions tend to build weaker cognitive maps of the areas they travel through, even after years of repeated trips. You can drive the same route to work for a decade using a navigation app and still be unable to sketch it from memory. Compare that to someone who learned the route once, manually, using landmarks and direction. The city etches itself into memory. The app version barely leaves a trace. Here's the twist though. It isn't that your hippocampus stopped working, it's that outsourcing the task means it never gets exercised in the first place. Muscles atrophy without use. So, it seems, does spatial memory. And there's a mirror to all of this that most people never notice. The same brain region responsible for tracking your physical location in space is also deeply involved in memory more broadly. Not just where you've been, but who you've been. Some researchers believe the reason